Okay, this video is about distributed property and about expanding in distributed property, factoring, and combining like terms. So if you recall, the distributed property of multiplication over addition, symbolically, it would look something like this, where you have a number or a variable on the outside, and then in parentheses, two numbers or variables that you're adding. And what happens is we distribute the variable on the outside to both pieces on the inside. And since we're multiplying by a, when you distribute, you get a times b. The plus doesn't change. And then you get a times c. Okay, if we were looking at it in terms of the area, if we wanted to find the area of this whole rectangle, it would be this side a times this full length, which would be b plus c. And that would give us this right here. Or we could find the area of these two individual rectangles and then add them. The area of this one would be a times b, and the area of this one is a times c, and then you'd add them. That's why these two are equivalent to each other. So our objective is to use distributive property to simplify numerical and variable expressions. We can use the distributive property with addition or with subtraction. So it doesn't change anything in terms of the operation. And if we were to look at the order of operations to prove that the distributive property is going to make equivalent expressions, we could follow that 3 times 4 plus 5 is the same as 3 times 9. 4 plus 5 is 9. And then 3 times 9 is 27. But if we use the distributive property, we would find that 3 times 4 is 12. 3 times 5 is 15. And that would give us 12 plus 15, which would give us 27. So you end up with the same answer using distributive property or using order of operations. That's why distributive property works. So let's try some examples now. We're going to distribute these and create equivalent expressions. So we have 3 parentheses x plus 7. We distributed 3 to the x. That would give us 3x. The 3 to the 7, and that would give us 21. The addition doesn't change, so it's 3x plus 21. We distribute the 2 for 2 parentheses a plus 4. That would give us 2a. And distribute the 2 to the 4. That would give us 8. So it's 2a plus 8. Next, we're going to have 7 parentheses 8 plus m. We distribute the 7 to the 8, which gives us 56. We distribute the 7 to the m, which gives us 7m. And the addition doesn't change. For this one, we're going to distribute the 3 to the 4, which gives us 12. And the 3 to the a, which gives us 3a. The plus doesn't change. For this one, we have the number on the outside, but we can still distribute it. We're going to distribute the 5 to the 3, which gives us 15. And then we're going to distribute the 5 to the k, which gives us 5k, and the addition doesn't change, so we end up with 15 plus 5k. Up here, we have all variables. It doesn't change anything. We're still going to distribute. So we distribute the x to the a and to the m, and that gives us ax plus mx. Ax plus mx. The order of this doesn't matter. You could have written ax or xa or mx or xm, but we want to kind of keep consistency with these variables on the end, so that's why we do it. For this one here, just going to distribute 4 to the 3, 4 to the r. We end up with 12 plus 4r. 2 to the x, 2 to the 8. We end up with 2x plus 16. We're going to distribute the 7 to each of the terms. 7 to the 2m, 7 to the 3y, and 7 to the 4, which gives us 14m plus 21y plus 28. 7 times 2 is 14. The m doesn't change, so that just stays there. 7 times 3 is 21. The y doesn't change because there's nothing to affect it, so that just stays 21y. And the 7 times the 4 giving us 28. Then finally, just like number 5, we have this 3 on the side as opposed to the left side. It's on the right. That doesn't change anything. We're going to distribute it to each of the pieces on the inside. 3 times 6 gives us 18. 3 times 2y gives us 6y. And then 3 times a gives us 3a. Okay, now you're going to try these ones. So you have 4y plus 7. That would simplify to 4y plus 28. 3b plus 6. 3b plus 18. 5, 9 plus m. 45 plus 5m. 5, 4 plus a becomes 20 plus 5a. Parentheses 7 plus k, close parentheses 6. And remember, just because it's on the outside, it still means multiplication. That would give you 42 plus 6k. Over here, we have a parentheses c plus d. That would give us ac plus ad. 7, we have 8 parentheses 3 plus r. That gives us 24 plus 8r. 8, we have 4, x plus y plus 1. 4x plus 4y plus 4. 9, we have 5 parentheses 2m plus 3 plus t. That gives us 10m plus 15 plus t. And then finally, we have this set up here for number 10. Now there's addition here, but there's no number to distribute. So we're not going to multiply this times the outside or times the inside pieces. We're just going to instead combine these two together, because we can drop these parentheses. That leaves us with 11 plus 2y plus 3y. This is not multiplication, this is addition, unlike the 5 and the 4 and the 8. And therefore, we're going to just do what's called combined like terms. If you have 2y and you have 3y, you add them together to get 5y. So why does this make sense? Again, we look at the geometrics of it. If we look at a geometric model and we have a side of 4, a side of 3, and a side of 7, and we're looking for the area of it, well, if we're looking for the total area versus the area of the two small pieces, we would find that the area of the full rectangle would be 4 times 7 plus 3, which would be 40. Or we could look at each individual rectangle. This would be 4 times 3. This would be 4 times 7. And 4 times 3 is 12, plus 4 times 7 is 28. And they're equal to each other because 12 plus 28 is 40. Looking at it with variables, we apply the same idea. The area of the whole thing would be 9 times 4 plus x, because that's how long this is. Or we could see it as two smaller rectangles, where this is 9 times 4. That's the area of this. And then the area of this would be 9 times x. They are the same. So whole rectangle is with parentheses. Individual rectangle is them distributed and then adding. All right, now let's talk about factoring. Factoring is when we look at a number, or in this case, a term, and try to identify pieces that can be broken up into. So for example, we have 15x. Well, 15x is the same as 5x times 3. 12a is the same as 2a times 6. 2x is the same as x times 2. 36a is the same as 9a times 4. And then finally, 27x is the same as 3x times 9. These over here are equal to their counterparts on the other side, but they're just broken up, or as we would say, factored. Well, factoring plays a role in distributive property, but when we use it with the distributive property, we have to find not just any factor, but the GCF. And the GCF, if you recall, is the greatest common factor. So we're going to find the greatest common factor of these two terms. So we have 15x and 12. What is the greatest common factor among them? Well, the x doesn't appear in either of them, so we would ignore the x. So we'd say, what's the greatest number that can be divided into both 15 and 12? And it would be 3. When we look at 30 and 42, this a has no role because it doesn't exist in both terms. So we look at 30 and we look at 42. What is the greatest number that exists in both of those in terms of factoring? It would be 6. Now, for 14m and for 21m, we look at them and we could look at the numbers first. Looking at the numbers, the greatest common factor of the numbers is 7. However, since they both share this variable, m is also a factor. So the greatest common factor for both of these would be 7m. And then finally, 16k and 40. Greatest common factor that exists between those? Well, this doesn't have a k. This does, so we can ignore the k. Focusing just on the numbers, it would be 8. Now, when using factoring, we can apply it to expressions and go from expressions that have no parentheses to ones that do have parentheses. So one type involves a distributive property in factoring, but it's in reverse. Rather than distributing, we're going to take out from both terms. So if we look at 12m plus 10, what exists in 12m and 10? What's the greatest common factor of 12m plus 10? Well, it would be 2. 2 is in 12 and 2 is in 10. M doesn't get touched because it doesn't exist in both terms, so we ignore it. So looking at this, if we took 2 out of here, out of the 12m, we'd end up with 6m. The plus stays there. If we take a 2 out of here, that would be 5 left over. So 12m plus 10 is the same as 2 parentheses 6m plus 5. Looking at this one, we have 15x plus 20y plus 30. What exists in all three? What exists in all three? Okay, well, what exists in all three is 5. 5 exists here, here, and here. So we take the 5 out. If we take 5 out of 15x, we end up with 3x. If we take the y and take out 5, we have 4y. And if we take out 5 from 30, we end up with 6. And when I say take out, I mean divide those. So 15x plus 20y is this plus 30 is the same as 5 parentheses 3x plus 4y plus 6. All right, let's look at 3. 14a plus 7. What is the greatest common factor that can become out of 14a and 7? That would be 7. What's left? Well, 14a divided by 7 would be 2a, and 7 divided by 7 would be 1. The plus doesn't change. 8m plus 12x plus 20, greatest common factor? 4. What's left over? 2m plus 3x plus 5. And you can check your answer by redistributing and see if you get your original problem. All right, let's try these ones then. 22k plus 33. You take out 11, and you'd be left with 2k plus 3. 24c plus 12d plus 18. 6 is the greatest common factor. You'd be left on the inside with 4c, 2d, and 3. 7. 15 plus 35t. Greatest common factor is 5. What are you left with? 3 plus 7t. And then finally, 9b plus 6 plus 21a. Greatest common factor? 3. What's left on the inside? 3b, 2, and 7a. All right, now let's talk about like terms. Like terms are variable terms that differ only in their coefficient. Only in their coefficient. So like terms would be, versus unlike terms, 7x and 3. Those are like terms. They both have x, and they have the different coefficient of 7 and 3. These would be unlike terms. They have the 7 and 3 like these two, but they have different variables, so they are not alike. They have to look exactly the same in terms of the variable. These are like terms, 5y and y. Even though this doesn't have a number, there is always a number there of 1. So 5y and y, they are like terms. Unlike terms would be 5y and y squared. This squared makes this not a match, so they are unlike terms. 10xy and 2yx, they are like terms. They both have an x, they both have a y, there aren't any exponents attached, so therefore these are like terms. The order doesn't change the fact that they're alike. These are unlike terms, 2a and 3ab. This has an a, this has an a, but it also has a b, and since this is lacking the b, they are unlike. 2/3 a squared plus b is like terms with 6b a squared. Again, the order doesn't matter. The a has a square on both of them. There's a b without any exponent, and the 2/3 and the 6 match up as numbers, like terms. 5x squared y is not a like term with 7xy squared. Even though there is a square, one is attached to the x and the other is attached to the y. These are unlike terms. And finally, 4p squared is a like term of p squared because they both have the p squared, but 4p is not a like term with p squared. So let's look at simplifying by combining like terms. We can simplify each of these to make smaller expressions or more simplified expressions. So 7x plus 4y plus 2x plus y, we can combine the x's to get 9x. We can combine the 4y and the y to get 5y. And since it's all addition, you're still just going to add them together. We don't combine them because these are not like terms. 3m plus 10n plus 4m plus 1. What are the like terms? The m's we can combine together to get 7m. And then the 10n and the 1, there's nothing they are alike, so we just drop those back down, and that is our simplified expression. 7x plus 3y, well, you can't actually simplify that, so it stays exactly the same. 6x, 5x, plus 2x plus 3, well, all of these can be combined, and that would give us 13x, and then we just drop down that 3 because it can't be combined with the 13x. 4k, 2j plus 6k plus j, we can combine the k's together to get 10k. We can combine the two j's together, the 2j and the j together to get 3j. That would give us 10k plus 3j, and that's the best we can do. Here, we can combine the x's together, but the 10 and the 3y can't be combined, so we have 21x plus the 3y, because they can't combine with anything, plus the 10. Next, we can combine the y squareds together and the two y's, but we can't combine them all together. So we combine the y squareds, which would be 3y squared plus 6y squared, and then the y plus the y, and that would give us 9y squared plus 2y. And it's plus 2y because it's not y squared, because we're adding them. They're just two y's. And then the last one, 3/7 m squared plus 4t plus 2/7 m squared plus t. Well, we can combine the m squareds together, and we can combine the t's together. So we end up with 5/7 m squared plus 5t. Now, we can now combine the distributive property with like terms. So on this one here, we can look at each of these problems and distribute and then simplify. So let's look at 3 parentheses a plus 4, close parentheses, plus 2a. We distribute first. That gives us 3a plus 12. And we just drop down our 3a. And then we can combine the a's together to give us 5a and then drop down the 12. So this becomes this expression. Over here, we can first distribute the 6 to the 5 and the a, which would give us 30a plus 6. And then we can drop down the 2a and the plus a and leave it like that. Now we can combine the 2a plus the 6a plus the extra plus a. That would give us 9a, 2, 6, and the 1, 9, and then plus 30. Down here, we have 5x plus 4 parentheses x plus 7. We would distribute. We would leave the 5x because it's being affected by nothing. And that would give us 4x plus 28 after distributing. Combine the 4x and the 5x to give ourselves 9x, and then drop in the 28. And then over here, we have 3 parentheses b plus 4 plus 2 parentheses b plus 5. We can distribute to each of them. So we distribute the 3 to both of those, which gives us 3b plus 12. We distribute the 2 to both of those, which gives us 2b plus 10. And then we just leave them as adding. Now we can combine like terms. The b's can be added together to give us 5b, and then the numbers can be added together to give us 22. All right, let's see if we can simplify these problems here. Number 5, what would that simplify to? It would simplify to 9x plus 28. 6, what would that simplify to? Eight x plus 3. Number 7, what would that simplify down to? 3a plus 9. Number 8, what would that simplify down to? 9b plus 6. Number 9, what would that simplify down to? 10m plus 2. And finally 10, what would this simplify down to? 8k plus 13.